Hello and welcome back to the second session of Warwick Data Science Society's Beginners Python course. So we're going to start today's session with a quick recap of the stuff we saw last time before moving on to some new content. So if you're watching this as part of one of our live sessions, if you have any questions based on the material last time or the homeworks, just pop that in the chat now. We'll have a moment to pause just before starting to run through any questions that you might have from last time. So we'll start with a recap of the material we saw last time. So the main body of what we saw was about these things called variables. And that's the way of kind of having memory in our Python code to assign a name to a bit of data so that we can use that later. And so depending on what type of data we're trying to store, be it text data, integers, or kind of decimal numeric data, we have different variable types. And so if we're storing text data, for example, we would use a string variable type. And so we can check whether Python has the correct type for our data by using the type function. We just put in either a variable or a value itself to see what type it is. And then we can convert using various functions like int, float, and string. And we saw right at the end of why types matter so much. We'll see a bit more in this session. And it all comes down to Python being a very flexible language and that it will do different things depending on what variable types you give it. And so that is really good if we want to have flexible code, but can lead to problems if our variable types aren't what we expect. And so we also had a look at printing. This is the way of outputting information to the user from our Python code. And so I said last time that we always need to use print to get Python to print something, to output something to the user. And that isn't technically true. And so it turns out that whenever we run code in Python or in Google Colab, Python will automatically output that value into the cell. But it will only do that for the last thing that you ran. So if you have a block of code that outputs multiple things, Python will only output the last one by default. If you want all of them to be outputted, you have to explicitly use print to say, I'm printing each of these things. So for example, if we had a cell with two strings, so 2 bits of text data, I won't be printed, but I will, and we ran this, the last bit of code kind of outputs that text. That's kind of the final thing we get to. And so that gets outputted below the cell. But the first thing will not, because we only output the last thing by default. If we want both of these to be printed, then we have to explicitly use print to say, I want to print these things. And so we saw kind of a bonus example in last session of how we can, if we have a variable, let me just connect to this, we can write something like, x is 3, the type of x. We can just run this and it will work fine. It's going to print out what the type is. It's an integer. But if you want to print out maybe the type twice, let's add divide by 2, say, we're only going to get the last one printed. If we want both of these to be displayed, then we have to put it in print. And do the same for, well, actually we wouldn't need to do the same for the second, but for consistency, let's do that. And so now we'll see both of them print. Now you might also notice that the output was slightly different there. Before it was just int, and now it's class int. And we'll get back more to that in a later session. Or if you're following along with the additional notes that you can find on the course webpage, if you go down to the bottom, there's some more details on the additional notes for session 1 about that. So it's best practice to use print, just to be clear. But if you're feeling a bit lazy, I guess, you can always omit it and just print things out directly, as long as there's only one thing. Okay, so the content of today's session is going to be, learning the opposite of last session. Last session we learned how to output things to the user. Now we're going to learn how to take inputs from the user to use in our code. We'll learn a bit more about variable typing and why it matters so much, and then look at these things called lists. And these are a compound data type that can be used to store multiple other values inside of them. But we'll see more about that later. So for now, if you're watching the live session, we'll just pause for a moment and answer any questions that may have arose from the previous session. See you in a minute. Okay, let's get started. So the first thing we're going to do is look at how we can take input from the user and use that in our code. So we saw before that we could use the print function to output information to the user to talk to them, but how can we get them to talk back and use that information to guide our code? So we can do this using the input function. And so this takes a single argument, so kind of a single value inside of the brackets. And this should be a question or prompt that's going to be asked to the user before they give their answer. And so this should be a string, and we can input that using double quotes. And then what we can do, the input function is going to return a value, and the value returned is going to be whatever the user types in as their answer. And we're going to assign that to a variable to store later. So for example, we can use the input function here, and inside the brackets we put a single thing, and that's going to be the question that we're asking the user. So what's your favorite color? And we put that inside of double quotes here. And so we can then run this, and this will return whatever value the user types in. So it's going to create a text box like this with the question above. They'll type in their answer, press enter, and then you can almost think of it as this whole command here, input, and then the brackets, is replaced by whatever the user typed in. And so this becomes essentially color equals to then the string blue. So we're taking that string blue and assigning it to the value of color. And now we can use color in our code, say for example by printing no way my favorite color is then that color 2, and then that color is going to be replaced with whatever value we set that to, which was the user's input. And so we end up with an output saying that we also had that same color as our favorite color. Now, for consistency, the input command always returns a string. So no matter what the user types in, whether they type in some text or a number, it's always going to return a string. And so this is good for consistency. We can guarantee what value we're going to get back, but it does mean that we might have to do some processing to make sure that our returned value is in the correct type. And so to do this, we can use one of the converting functions like int, float, or something like that to convert the inputted value into a new type. And so we might want to do this, say if we're going to do maths with the value inputted by the user, we're going to need to store it as either an integer or a float. If we try to do maths with the raw string, it's not going to work correctly. So for example, if we have an input saying how many apples do you need to make a pie, and then assign that to the variable apples, even when the user types in the number 5, when we print out the type of this, this is the string 5, so 5 in quotes. If you try to multiply that by a number, I think we saw that in the additional notes of last time, but basically it's something strange happens. And so we want to make sure that we have it as an integer before carrying on. And so to do that, we'll take apples, this value we had returned by the question, and convert that into an integer using the int function. Take that output, the integer version, and overwrite the current value of apples with this converted version. And so now apples is an integer. If we print out its type, we get integer. And if we multiply that by 5, we get the correct answer of 25 when we go to print that out. So we just had to take that and convert that into an integer. So this is quite a lengthy way of doing it. I'll quickly show you a more elegant way to do it in one line. So I could do something like, we're going to do the same again. So we'll have apples is equal to how many apples in a pie. And rather than on a new line doing something like apples equals the integer version of apples, we can actually do this on one single line by putting the int at the start here. So here we're doing something called nesting functions. So nesting means putting one thing inside of another. So I'll put some spaces here just to make it clear what's happening. Those spaces don't really matter in Python most of the time. So we run this input function that's going to ask the user a question and then kind of replace itself with whatever value is outputted. So let's say we run this and type in the number 5. This is going to be almost replaced with the string 5, and then we convert that into an integer using the int function. So we can nest these two functions together to kind of do this in a bit more of an elegant way. So with that, we're going to have a go at doing some user input for ourselves. We're going to base this on an example we saw in the homework of last session. So you might want to open up your homework, but if you haven't done that by now, the question is written here, so you can just base it off that. So with that, we'll just pause for a moment and then come back to see the solution in a second. Okay, let's have a look at the solution to that. We'll actually go through it in a notebook directly, just because it's a bit of a lengthier question than we're used to. So we'll break it down bit by bit. So the first thing is to create 3 variables, chickens, cows and pigs, which are going to have the number of each of those animals on the farm. But we're going to, rather than manually assigning these, get these values by using user input. So for example, we can have chickens and have that set to be equal to asking the user using input how many chickens are there. We can then take that and we can replace chickens with, and cows was the next one, and then was it pigs as well. I'm using a nice shortcut here. If I hold on Alt while selecting in Colab, I get multiple cursors, and so I can type in multiple places. So I run this, it's going to ask how many chickens are there, so there's 4 of those, how many cows, there's 3, and how many pigs, there's 5 of those. And then what we want to do is print out how many total legs there are on the farm. So we're going to start by printing this out as it is, and then add the text around it to make sense. So what value are we going to want here? Well, for every chicken, there are 2 legs. So we'll do 2 times the number of chickens. Then we'll add on 4 times the number of cows, because there's 4 legs on each cow. And 4 times the number of pigs. And finally, we'll add 2 for our own legs. So if we print that out here, why didn't it like that? Okay. Oh, because we didn't convert these to an integer. Like that was the key message that I was trying to share with you earlier, and I forgot myself. So it proves it is an important thing to kind of really pay attention to types. So these were the integers for what numbers we entered there. Let me just show that quickly. I print out the type of a pig, say. This is a type string. It is the string 5. We wanted this to be an integer. And so I can take these inputs and wrap it in the int function to make sure that we have it as the correct type. So now we can put those in, 4, 3, and 5 as before. They then get converted to integers using the int function, and we can now do maths with them. And that works fine. And so now let's just add a bit of text around that. Let's put there are, then a comma, and then we'll end it off with legs on the farm. And you'll see here that between these commas, I put a new line. Python generally doesn't care about spaces and new lines, and so we're free to, rather than having a really long line here with everything on, we're free to put it over multiple lines just by putting these new line characters in. So if I print this out, I get there are 42 legs on the farm. And so we can see that same solution here. So taking the input, converting to an integer, and then I made a slight tweak here where rather than doing the number of cows by 4 and the number of pigs by 4, I add them together first and then times by 4. But that means the same thing, really. The key thing, and the thing that I forgot, showing that it really is important to pay attention to this, is to convert to an integer before trying to do the maths. And as I mentioned, the extra white space and new lines here, Python doesn't care about it. It's more focused on the characters you type rather than how they're formatted. That just makes it easier for us to read as a human. Okay, so let's have a bit more of a look into why variable types matter. And so the main reason for this is that a single function or a single kind of mathematical operator like plus will behave differently depending on what type its inputs are. So for example, we saw at the end of last session that if we add 2 strings together, they get concatenated into a single string, just gluing them together. And similar to this, if we take a string and times it by an integer, I think I mentioned this earlier, is that what happens is we get that same string repeated that many times. And so we had echo times 3, we get 3 lots of echo as a single string. And so this is very useful, this is very flexible, but it can cause us unexpected issues if we're not aware of what type our variables are. And also, there are limitations to this. So if we try to take a string and times it by a float, even if this float really is an integer, well then it's going to give us an error because Python is not that flexible. So to resolve this, we'd either have to remove the 0.0 or convert this to an integer by doing int of 3.0. And so here is a question. We're not going to kind of pause for too long. If you're watching the live session, we'll pause for a moment, and I want you to have a think about what could go wrong with this code, and perhaps in the chat, pop down what you think an input could be that would break this, and hopefully someone will come up with an answer that's still technically correct, but would break this code. So we'll join back in a second. So hopefully you've had a think about what could go wrong with this code, and perhaps if you're in a live session, pop an answer in the chat. And so we'll now have a walk through what such an example might be. And so this is kind of a really good example of how even inputs that might seem sensible to the user can cause problems with your code if not considered correctly. And so something that could go wrong is if the user enters their answer as a string, like as the text version of the answer. So we ask them what is 4 times 6. If they were to answer the number 24, that would be fine. The return value would be the string 24, but when we put that into int, that will get converted to the integer 24 and we'll have the correct response, the integer 24. But if they answer with the words 24, when we go to try and convert that into an integer, it's going to fail because there's no integer version of the text 24. And we get this error here saying invalid literal for int with base 10. And that's a very verbose way of saying there's no way I can convert that into an integer. And so we could have, the user could have inputted something like 24.0. That would have been converted to an integer just fine. But if it was text, then there is no way of converting that. And so we'll learn later in the course how we can handle input like this to validate it and ask the user to respond again if their answer wasn't valid. But for now, we'll just assume that the user always gives things that are correct. Okay, so we're going to take a tangent from what we've been previously looking at and look into some more kind of powerful computation with Python. So we've seen how we can do mathematics with kind of single values, 3 plus 2, and that sort of stuff. But we're using Python to try and leverage the language to solve problems that are more complicated than what we can do with a normal calculator or with Excel. So one useful thing we might want to do is to take a whole collection of numbers and calculate the sum of all of those. And so we can do that using a function called sum, but we're first going to need a way of storing this collection of numbers. And so one way of doing this is using a special type of variable called a list. So we'll talk about these a bit more later. Basically, a list is a special type of variable that can contain other variables or other values. And so for now, we'll just learn how to make one. And to do this, we use a pair of square brackets and fill it with values separated by commas. And so when we've created a list, we can then put that as the input to the sum function, and it will add up all the values. So we can create a list with square brackets and then fill it with several numeric values separated by commas, and then we can assign that to the variable numbers here. So now numbers represents this list we created on the right. We can put numbers into the sum function, and that's going to add up all the values in that list and assign that to the value total. Now we could have just put the list directly inside of sum, that would have worked correctly too, but here we just put it into a variable temporarily first. Finally, we print out the total and we get the number 22 as we would have expected from this input. Okay, so we're going to pause again for a short puzzle so you can have a go at applying the sum function for yourself. Okay, let's take a look at the solution to this exercise. And so it's very similar to what we had before, except we're now outputting to the user in a kind of a sentence rather than just putting out the value. So we take all of our numbers in a list, so square brackets, then values separated by commas, assign that to a variable nums for later use, and then sum that all up into total. And then we print out a string saying the total of your numbers was, and then the total there. And we don't have to put a space at the end there because whenever we print multiple things, as I said in the last session, Python will automatically add a space between those. Okay, and so just as with the sum function, there are functions in Python for calculating the minimum and maximum values in a list. And those are, quite unsurprisingly, min and max. And so we use them in the exact same way by passing a list into them as their only input. So for example, we could have a list of people's heights, and then we could put that inside of min or inside of max to acquire the minimum and maximum of those heights. Now I'm going to take a moment to point out something that can go wrong when we're trying to do this. So let's create a list here. So it's going to be, I guess we'll do heights again. And they're going to be 147, 163, and 171, let's say. And let's calculate the minimum of these heights and assign this to a variable called min. So min is equal to the minimum of those heights. And then let's print out min. So this code looks okay. There's nothing kind of glaringly obviously wrong with it, but there is a bit of a problem. And so we'll run this for the first time and see what happens. Great, we get 147. That is indeed the minimum of the values in that list. But now let's run it a second time. And we get an error. So that's really strange that we could run something the first time it was fine, but the second time, and if we run it a third or fourth, we're going to keep getting an error. And so the error we're getting is really quite vague. Int object is not callable. And so there's lots of errors you can get like this, which kind of revolve around something is not callable. And so the most likely cause for this is that you've created a variable that has the same name as a function inside of Python. And so the problem that occurred here is that we created a variable called min, and min is already used for the function name of the function to calculate the minimum of a list. And so the reason that this can happen is that pretty much everything in Python is a variable, or the technical term for it is an object. And so min is just, well, okay, let's look at max for now, because we've broken min. If we take the max function and put it without brackets, the brackets are used to actually run it, and we ask, what is the type of this? We'll see it's of type built-in function or method. It's basically a function that comes built into Python. So this is just like a normal variable, a normal object, and because of that, we're allowed to overwrite it just as we could overwrite any other variable. And so what happened with this code here, when we ran it the first time, is we took the minimum of heights. Min was still defined correctly to be the function to calculate the minimum. And that was whatever number we saw, 147. And then assigned that to the variable min. And in doing that, we overwrote the existing value of min, which was the function min. And so now when we come to run this a second time, what Python sees is this 147 of heights, because min has been replaced with the value 147. And that doesn't make any sense. So we can't run a number. We can run a function, but can't run an integer. And that's what it means here. We can't call this integer object. We can only call a function. And so if we do something like this, we can get everything back to normal by going to runtime and clicking, what is it going to be? Restart runtime. That's basically turning the processor we're using for Colab on and off, sorry, off and on, so everything's back to normal. And now we could maybe rename it as min height. And now if we go to print out this, we can keep running this to our heart's content, and it's never going to give an issue. So just be wary. If you see something like this coming up, you're going to restart things and figure out which variable you've used, which is also the name of a built-in function that you've overwritten. Okay, and so we're going to have a look at a puzzle now, and this is going to be an actual application of that lesson we just saw there, because we're going to calculate the range of a variable. Now there's no range function. Okay, so there is a range function in Python, but it doesn't calculate the range of a list. It does a different thing, which we'll see later in session 5. But the important thing is we can't create a variable called range, or we can, but we'll run into issues if we do so because it's a name used for something else. So instead, we should use something like maybe spread or difference instead of the word range when creating that variable. So let's have a go at this and we'll join back again in a few moments. Okay, so hopefully there was no trouble with that. Let's now have a look at the solution to this exercise. So it'll look something like this. So we have a list called mynums, and it has these values here. We want to calculate the minimum and the maximum, and then we assign those to variables smallest and largest. We can't call these min and max. That will give us issues by overwriting these variables, or these objects, these functions. We can then take the largest and smallest, and take the difference of those two to calculate the range of our data. And so we can then save that to a variable called spread. We could save it to range, but then if we went to use the range function later on, maybe once we've learned session 5, we'd run into issues because we would have overwrote that functionality. And then we can print out some sentence and the spread to get something like this here. Okay, so the final thing we're going to look at is how to get the length of a list. And we can do this using the len function. So len and then brackets, then inside the brackets we put the list we're interested in. For example, we have a list of numbers 4, 5, 2 and 6. There are 4 values in this. If we put that into the len function, then kind of print out the output of that, then we'll get the answer 4. Didn't show it here, but this would give 4. And so, no, I think I mentioned this before, but we'll reiterate it. We could just take this list and put it directly inside of len. That would work fine, because whenever we see a variable, Python just replaces it with the last value it was set to. So putting the list directly in and putting in the variable essentially mean the same thing. Okay, and so we mentioned when we talked about strings for the first time that they're called strings because they're basically a string of characters, a series of characters, or I guess you could say a list of characters. And so strings and lists are different things, but they're very closely related with how Python stores them. And so a lot of the things we can do on lists, we can do on strings and vice versa. And so the len command also works on a string and will tell us how many characters, so including spaces and periods, various things like that, are in the string. For example, if we create a string isn't Python great and assign that to sentence, we can print out the length of that sentence. It's going to give us how many characters there are, including the apostrophe, space, and exclamation mark. So we'll see more examples, I think, in session 4 about how strings and lists have things in common. But for now, just keep that in the back of your head that a lot of these ideas can be applied across both types of object. So with that, we'll pause for the final set of puzzles, have a go at this, and then we'll wrap up the session. Okay, let's take a look at the solution then. So we're asked to ask the user for an input and then print out the length of whatever they write. And we can do this by using the input function, so say something, and then so that's our prompt, and then we take the answer and put that into the variable text. And then we can then print out as a sentence or just the length itself. So your sentence was, use the len function to get the length of that text, so the number of characters in whatever they inputted, and then characters long. So we can say your sentence was 23 characters long. Okay, so that's the end of today's session. I hope you've enjoyed and enjoy applying these in the homework sheet. So we'll see you next time.